With our do now this morning, we're going to get a nice review of our converting from scientific notation to standard form and standard form to scientific notation. One of the things I want to remember is that a big number is a positive exponent. So a big number is going to have a positive exponent in scientific notation and vice versa, and that a small number is going to have a negative exponent in scientific notation. Okay, and that's going to help me as we convert from one to the other. So write the following number in standard form. My first step is I'm going to rewrite that significand or mantissa. Look to our exponent, -3, so our decimal is going to move 3 spaces. Negative exponent, small number. So to make this a small number, I would move the decimal to the left. So we're going to move the decimal to the left 3 spaces. 1, 2, 3. Put in our new decimal and fill in with 0. So our number in standard form, 0.0062. And we box it. Okay. Same process for number 2, 2.7 times 10 to the 5th. I'll rewrite my significand. Our exponent is 5. We're going to move the decimal 5 spaces. It's a positive exponent. To make a big number, I would have to move the decimal to the right. So we move to the right 5 spaces. 1, 2, 3, 4, 5. And fill in with our zeros. So we wind up with 270,000. Perfect. Now, numbers 3 and 4, we're taking a number in standard form, writing it in scientific notation. My first step, I'm going to box what will be our significand. So that'll be 506. We have to put a decimal point in to make that a proper significand between 1 and 10. So we'd have to put that right there in between the 5 and the 0, and then count our decimal places. We've got 1, 2, 3. So that's going to be 5.06 times 10 to the, it's a small number, and we said it was a 3 space, 1, 2, 3, to the -3rd. 5.06 times 10 to the -3rd. Okay. Number 4, 783, well, that whole thing is our significand. We'd have to put a decimal point between the 7 and the 8 to make it a proper significand, where we're moving the decimal point 2 spaces. So 7.83, and it's a big number, times 10 to the 2nd. Okay, and there we are. Okay, so we're going to go ahead, we're going to take a look at how do we multiply and divide numbers in scientific notation. Once we know how to do that, it really gives us an opening into some of the applications where we use scientific notation. So as we go and we do our multiplication with scientific notation, the whole idea and convenience of multiplying with scientific notation is based on our commutative property. So if you remember, our commutative property tells us that in multiplication that we can change the location or the order of our numbers without affecting the product. So we use that as our tool. So we're going to do that here with our numbers in scientific notation by moving our significands around, our decimal numbers, to group them together and multiply that, and then group our powers of 10 together, where now we can use our rules of our exponent, our multiplying with same bases, where we're doing keep the base, add the exponent. Okay, so we've got an example worked out there for us in our box. Let's do one together. Okay, so we've got 1.1 times 10 to the -5th times 9.9 times 10 to the -1st. So our first step, we're going to regroup our significands together and multiply those. So just using our commutative property. And if you want, you can show it in parentheses, don't necessarily have to. We're going to do 1.1 times our 9.9. Okay, and then we're going to have regrouped together our powers of 10 there. So we can put those in their own group, that we're going to be doing 10 to the -5th times 10 to the negative first. Now, the last time we did this scientific notation was in school, and we didn't allow students to use calculators, so they had to go and do their decimal operations off to the side. So you guys should feel very fortunate and happy that you're allowed to use calculators while at home. So we'll grab our calculator. 1.1 times 9.9 is 10.89. And then our powers of 10 there, we're going to use our exponents rule where we're going to keep the base and add our exponents. So it's going to be 10 to the negative 5 plus negative 1 power. Negative 5 plus negative 1 is 10 to the negative 6th. So we get 10.89 times 10 to the negative 6th. Now this is a point where I see students and they say, oh, I'm done. No, you are not done. This is not proper scientific notation. That's not a proper significand. It's too big, okay? It is not proper. It is too big. Okay, so we have to adjust it. So we need to move the decimal place one space to make it 1.09. Moving it one space on a significand that was too big, positive exponents, we're going to add 1. Thus making our answer in proper scientific notation form 1.089 times 10 to the negative 5th. Okay, so now that's proper. That's a final answer. Okay, so we're going to go do essentially the same thing, but with division. In dividing our numbers with scientific notation, we're going to take the same steps, whereas we're dividing, we're using our commutative property, we're regrouping where we're dividing the significands versus dividing our powers of 10. As we go to divide our powers of 10, we're going to be doing our rule for division, which was keep the base and subtract the exponent. So we're not really going to be canceling out like we did with our exponents, but more using that rule because it's okay to have our negative exponents in scientific notation. So let's go ahead, let's put it into practice in our own example. So our first step we're going to do is we're going to rewrite as a fraction 3.2 times 10 to the 8th divided by 4.0 times 10 to the negative 2nd. So that's 3.2 times 10 to the 8th divided by 4.0 times 10 to the negative 2nd. Remember, it's top divided by bottom. At this point, I can kind of separate out our significand versus our powers of 10, right? So that's 10 to the 8th over 10 to the negative 2nd. I think it's helpful to see it as a fraction because it helps students to see what's getting divided by what. So I'll grab my calculator, 3.2 divided by 4. That's going to give us 0.8 in our significand. And then in our powers of 10, remember we're going to keep the base and subtract the exponent. So it's going to be 8 minus, what are we subtracting? That negative 2. So careful there, right? We want to remember double signs, right? Same sign, sum. It's actually going to be 8 plus 2. Right? So we go ahead, we get our answer of 0.8 times 10 to the 10th. But wait again, oops, that significand is not proper. This time it's too small. So we have to fix that. To fix that, we need to move the decimal point one space. Okay? We moved it because the significand was too small. Small negatives, we're going to subtract 1 from the exponent. So that makes our answer 8 times 10 to the 9th. Okay, so keep that in mind. Write yourself a reminder maybe at the top of the page as you're going and you're doing page 8 for your classwork that your answer has to be in that proper scientific notation form. Tomorrow we're going to start working in word problems with our multiplication and division, so make sure you're getting a good practice with the operations. This way the word problem, the reading, and the vocabulary are really what's new for tomorrow in the challenge and not the operations themselves. Today's math jokes for Matthew folks is a classic. One of the favorites of some teammates of mine in college was, why is 6 afraid of 7? because 7, 8, 9. Have a great day, guys.